You guys saw work, power, energy, right? Now, before we start with the similarities and dissimilarities and what it is and how they are different, so there are certain prerequisites which you guys have to know. Okay, so the first and the foremost and very important is vectors. Now, vectors you have already learned very small and few things about vectors, right? Now, here in this particular thing, what you guys need is scalar product or dot product of two vectors. Okay, so this is a dot b. Now you have to pronounce it as a dot b only, never pronounce it as a into b. Okay, so it's a dot b. Now here you have two vectors, right? A and b, two vectors. Now let's consider that this is vector a and this is vector b. Now the angle between them is theta, right? Now if this is vector b, now remember resolving a vector we did. So the same thing you guys will do here also. Now if you resolve the vector, now vector b projects itself onto vector a, right? That projection will be nothing but b cos theta, right? If you resolve it, you guys will get that. So the dot product of vector a and vector b will be a into b cos theta. So we get a dot b is equal to ab cos theta. Alright, so this is the scalar product or dot product. Now why we call it as a scalar product? Because the magnitude part is only we are calculating, correct? There is no direction here. So this is the reason it's a scalar. Now very important point, both the vector a and vector b, see these two are vectors, right? But the product of these two, that becomes a scalar. Alright, so very important point here is that here we are talking about the cos theta component. Okay, so cos theta component. So since we have cos theta component, so when the angle changes, the value of the dot product will also change. Alright, so in the next video you'll see few properties of scalar product, like what happens, so is distributive law true, commutative law, and lot of other properties you'll see about the scalar product.